right. So this is part 2 of the video series going over Dali and Math. And in the last video, and if you didn't watch it, please do so because it explains what the golden ratio is. So we use the golden ratio, we can create golden polygons. So the 3 that I have up on the screen that we're going to see Dali use is a golden rectangle, the golden triangle that is an isosceles acute triangle, and a golden triangle where it's also isosceles, however, it is an obtuse triangle. So let's talk about the golden rectangle really quickly. We see that the dimensions of the sides, one dimension is 1 and the other dimension is 1.618, therefore making the golden rectangle. So if you want to know if something is a golden rectangle or not, you're going to divide length by width. And if you get 0.618 or if you get 1.618, then you have the golden ratio. So for instance, if I take my credit card and I measure it, and if I measure the length and I divide it by the measured width, and if I get 1.618, then it's a golden rectangle. By the way, most of your credit cards do hold those proportions, and that's done so on purpose, by the way. So the next one over, in the center we have a golden triangle that is acute. Acute means all angles have to be less than 90 degrees. Remember that the interior angles of a triangle have to sum to 180. So we see we have 2 angles that are of equal measure. They're both 72. Therefore, the third one has to be 36. So what does an acute isosceles triangle mean? Isosceles means you have 2 equal sides and 2 equal angles, okay? And then you can also get a golden triangle with an obtuse isosceles triangle. Obtuse means that one of the angles has to exceed 90 degrees but fall under 180, and we see that with that one angle being 108. Then the 2 others have to be the same measure for it to be an isosceles triangle. So that's why the other 2 are both 36. All right, so moving on. If you want to construct your own golden rectangle, you have to start out with a perfect square. Remember, a square has equal length sides. So if you construct a square and you find the midpoint between D and C, that would be point E. If I put a compass with its point in point E and stretch it up to the upper right-hand corner, which is point B, and pull it down, I now have a point F if I extend the line D through C, then through F, okay? Once we get point F, I can draw a line that is perpendicular or 90 degrees away from line segment DF. So I get that nice vertical line there. And then all I have left to do is connect point B through that vertical line where F is, and now I call that point G. That is the golden rectangle. So that's what it looks like, and if, like I said, if you want to make your own, you can do that with the ratios. What can we do with those proportions? There are other shapes that are formed with the golden ratio. Other ones of note are a regular pentagon. Regular means that all angles have equal measure and all sides have equal length. And if we look here in green, it shows a value of 1, and red shows that value and how it's related to pi. So a star was very sacred to ancient Greeks, and in fact the Pythagoreans had a star inside a pentagon tattooed on their palm to let them have access to talk about things like math, science, philosophy, and music. So it's very important, and once again, this is not a devil-worshipping pentagram or anything like that. For starters, the star is pointed upwards, and that pentagram, I believe, was created with Hollywood. So you know how Hollywood messes up stuff. So we're going to go on to the golden triangle. There's a golden triangle embedded in a regular pentagon, which is not really too surprising. And once again, that triangular form is actually an acute isosceles golden triangle. Remember, that means that two angles have to be less than 90 degrees that are the same. So we get 72 degrees, and then the final one has to be 36. So where did the ancient Greeks utilize this? I mentioned before the Parthenon in Athens. So the Parthenon stood up on a hill called the Acropolis. So it's basically a city on a hill. And once it was in its full glory, it didn't really look like this. This is now in ruins, but I promise you that if it was completely, back to where it was in ancient Greek times, the top of it is actually an isosceles obtuse triangle that creates what's called the pediment. By the way, this is a crime against, I think, humanity and art. In the early 20th century, the British went over to Greece, with their permission, by the way, and sawed off the top portion of the pediment that showed the Greeks fighting the gods. This is called the Elgin marbles, and many people think the British Museum should give it back to Greece because that is, part of their heritage. But there's a big debate and controversy over who should have it and who shouldn't. So currently it is still at the British Museum. Just to let you know, can you imagine someone sawing that off after it has stood there for thousands of years? But at any rate, one plus note about the Elgin marbles are they are being well taken care of. The British Museum, I will give them that, does take care of their artifacts. By the way, the Rosetta Stone is there as well. So, like I said, it's a whole nother debate in and of itself, but I just wanted to show you that. And also, the whole entire temple that we're seeing here is based off of those proportions. Why? Because Phidias, who Phi is named after, was the architect that designed the building. All right, so Dali. Let's talk about the Renaissance masters and how Dali uses it. Well, first of all, a person who always used it in almost all of his work was Leonardo da Vinci. And by the way, his name means Leonardo of Vinci. So that would be like me saying I'm Joanne of St. Pete. So when people say Leonardo, you're basically just giving me some guy's name. Is it Leonardo da Vinci? Is it Leonardo DiCaprio? Who are we talking about? So if we put Da Vinci, that means of Vinci. And once again, some people say Da Vinci, and that just means of Vinci. So are we, that'd be like me saying, oh yeah, that artwork's done of St. Pete. It doesn't make sense. So you kind of need both parts to be, kind of taken seriously. Anyways, he's quoted as saying, "Let no one read me who is not a mathematician." So for Leonardo, his best friend and his roommate at the time was a mathematician, and Leonardo said, "Sure, I will illustrate a book for you." So he did, and this is one of the pages from that book. Also, Leonardo da Vinci drew up the Vitruvian Man, which I know you guys probably saw this. By the way, it's 1492, same year that America is discovered by Christopher Columbus. Now, I know some of that's been debunked because they said the Vikings arrived here long before that, but I'm just going to go with the 1942 vibe here. I know for a fact Vitruvian Man was drawn that date. So we see a man posed inside a circle and a square. A square for ancient Greeks mean earth, and a circle means heavens. So you'll notice that the Vitruvian Man, his fingertips are at the intersection, or the top fingertips, I should say, with his arms stretched upward, are the intersection of the circle and the square. So Da Vinci, Leonardo da Vinci, is making a statement that man is a conduit between heaven and earth. So it's very interesting. By the way, his proportions are based off a physician whose name was Vitruvius, and Vitruvius created a notebook saying what the proportions of the perfect human form should be. Now, for me, the Vitruvian Man kind of looks like, if you know who if you've heard of the band The Doors and you know who Jim Morrison is, it kind of looks to me like Jim Morrison making snow angels in the nude. But anyways, let's move on. So this is showing the golden ratio. Excuse me 1 second. Coco, no, come here. Come here. Hold on 1 second, guys. I just don't want us to be interrupted again. Coco, come here. Do you want a treat? Come here. Okay, back to this. Sorry about that. That was your, my dog is yappy. You can kind of hear that. Anyways, so if you look from the navel of the Vitruvian down to the base of his feet, and from the navel to the top of his head, that is showing the golden ratio. So if we would divide those lengths, you would see it. Also, there is some triangular forms from the genitalia up to the upstretched arms, and from the genitalia down to the line in which the downward drawn feet are. That is showing some symmetry. It's not the golden ratio, though, just to let you know. All right, so the Lady of the Hour, Mona Lisa. She is one of the most famous paintings in the world. I mean, people go crazy. If you've ever been to the Louvre Museum, that's where the Mona Lisa is because Napoleon stole it. And, by the way, fun fact, he kept it in his bathroom. That's why the paint is crackled. If you go to see the Mona Lisa, prepare to wait in line because people want to see it and take pictures of her, etc. The painting itself is encased in, I think it's plexiglass or glass. So, if you take a picture, make sure your flash is off or else you're going to have a really crappy picture. But nonetheless, the Mona Lisa, like I said, is extremely, extremely popular there. So, I have shown you, if you look at her face, there's a golden rectangle that is composed from her chin to the tip of her head, and also from the middle bridge of her nose down to her chin, and from the bridge of her nose up to the top of the head creates that golden ratio. You're also seeing something that I didn't talk about yet, which is a golden spiral. So if you start at her left nostril, like in the center of her nose, there is a spiral that is shaping her face. She's also encompassed in an acute isosceles triangle that's golden. And Da Vinci knew about the golden ratio, so he is utilizing it to place things on the canvas. So when we talk about the golden ratio and visual arts, we're looking for placement of things. Like, for instance, look at the intersection of that curve from the golden spiral on her hand. Look at where she's intersecting. Her body is fitting inside of that triangle. So that's what the golden ratio is, and that's how it's done with at least Leonardo da Vinci's piece. Michelangelo's Holy Family, I'm just showing you grid lines. Once again, we're placing things on these grid lines to make it more aesthetically pleasing to the eye. Here's another one. This is by Raphael, one of Dali's favorite artists. This is called the Cowper's Madonna. And just for fun, that mask I showed you for the golden ratio in the last video? I placed it on her face, and voila, it fits pretty darn good. So, the other person that knew about the golden ratio was obviously Raphael. Okay, by the way, when I come back, remind me to tell you guys a story about Raphael versus Michelangelo. It's really fun. Okay, so moving on, let's talk about Dali and his use of the golden ratio. So in order to do this properly, we need to talk about Prince Mattia Gaika's connection with Dali. So here's an image of the prince. And by the way, he was a Romanian prince. He was a sailor. He was a mathematician, a poet, and also, a person who was able to sail really well. I don't know if I mentioned that before, but it's good to mention it twice. He also wrote this book, The Geometry of Art and Life. And there is a quote in this book that I think kind of summarizes the book very nicely. It says, "There is a geometry of art as there is a geometry of life. And, as the Greeks have guessed, they happen to be the same." So he basically takes the golden ratio of the ancient Greeks and he modernizes it. So for instance, we have something that looks kind of like the Vitruvian Man, just a little bit more modern, showing with the legs straight up and down. And we can see that he's usually using pieces of phi, like you can see the square root of 5, for instance, to come up with these proportions. And also, I showed you a very modern mask by the person who does the plastic surgery for the rich and famous in Hollywood. But this one is a little bit more archaic compared to that because it was done in the 40s. But this is one of the pages of his books. So you can kind of see phi, square root of 5 plus 1 over 2 being utilized to create these grid lines based off the golden ratio to check for proportions. And also there is a page that I wanted to show you that looks like this. And the reason why I'm showing you these pages is because we're going to see them in Dali's artwork. He literally takes the grid lines off the page and utilizes them. So this one's important. Here's an analysis of a Greek vase, which is not surprising that it follows the golden ratio and we get that beautiful golden triangle inverted. And also, here's an inversion of that page. Whoops, sorry. It looks like this. Okay. So I'm going to stop here because this video is getting rather long. And I'm going to pick up again and we're going to watch the rest.